Wow, here we are jumping again to a new chapter. So now you need to move to chapter 5, and we're going to work on section 5-2, which is on limits to growth. First of all, we have to determine what is a limiting factor. And a limiting factor is a factor that causes population growth to go down. In the previous podcast, we talked about 4-2, we talked about part 1, we talked about competition and predation, and this is going to add to that information that we had in that particular podcast. So once again, a limiting factor is a factor that causes population growth to decrease. What are some of these limiting factors that can affect population? Competition, which we talked about in the previous podcast, predation, and parasitism and disease. So we just introduced them in the previous podcast, and now we're going to talk about them in a little bit more detail. Also, we're going to add drought and other extreme climates to this list, and human disturbances. So we've briefly discussed the first 3, we're adding on the bottom 2. So, how does this occur? A resource space that is limited can also affect the long-term survival of species. So, for example, the panda population is one of the most endangered species today because pandas depend on bamboo for food and the forests are being cleared for timber and farmland. So that would be an example of a limited resource that is going to help with the survival of animals, specifically pandas and bamboo. There are specific factors, or maybe I should say there are 2 types of limiting factors. The first type of limiting factor is a density-dependent factor. Now, once again, you see that word dependent, and that's one word that we've used before when we've talked about the scientific method. So this means density is dependent upon something. So let's see what that definition is. A density-dependent limiting factor is a limiting factor that depends on population size. So here we go again. Density dependent depends on population size. These factors operate most strongly when the population is large and dense. So the population here has to be large and dense. They do not affect small scattered populations. So this is one key point to remember. They do not affect small scattered populations as greatly. Density dependent, once again, they're dependent on a large population. They include competition, predation, and parasitism and disease. So once again, the 3 that we've talked about in podcast 4-2 part 1. Let's review what these are again. So competition is when populations become crowded, organisms compete with one another for, and it's not necessarily, they compete for all different types of resources. So they might compete for food, water, space, sunlight, and other essentials. Competition among members of the same species is a density-dependent limiting factor. The more individuals living in an area, the sooner they will use up all of the available resources. So the larger the population is, the more they're going to eat, the less resources or space or whatever they need to survive is going to be available to them. Competition can also occur between members of different species. This type of competition is a major force behind evolutionary change. The species may evolve to occupy separate niches. So back in podcast 4-2, we looked at the competitive exclusion principle, where there was the tree, and then it had the 3 different warblers that lived in the same tree, but at different levels in the tree. And this is to avoid competition. So the species evolved to occupy different places in that particular tree. Once again, we revisit what we did in 4-2. No 2 species can occupy the same niche in the same place at the same time. And once again, this is an extremely important concept to remember. No 2 species can occupy the same niche in the same place at the same time. Predation. A predator-prey relationship is the regulation of a population by predation. And the example that was used in your book was the wolves and the moose on Isle Royale, and you're going to be doing a lab that's going to look at this specific predator-prey relationship. So we'll delve into this particular thing just a little bit further in lab tomorrow. Parasitism and disease. Like predation, parasites take nourishment at the expense of their host, often weakening them and causing disease and death. And we talked about the difference, exactly what the host was, and that the host was usually larger than the parasite that was going to live off, which is usually like a tick or a flea or lice. We saw that, or a tapeworm. That's going to be the parasite. It doesn't really always want to kill the host, because it kills the host, then it doesn't have anything to live off of. So parasites can also limit the growth of a population. So these are 3 ways that are density dependent variables. The other type of factor is going to be density independent factors. Density-independent limiting factors affect all populations in similar ways, regardless of population size. So they're independent, means they do not depend on population size. So these affect all populations in the same way, whether they're big, medium, or small. Density-independent limiting factors include unusual weather, extreme hot or cold, natural disasters such as storms or hurricanes, seasonal cycles such as droughts, and that's been a huge factor here in the United States, and human activities such as damming rivers and clear-cutting forests. All of these do not depend on the size of the population. So if a natural disaster comes through a specific area, it affects everybody equally. Many species show a characteristic crash in population size when there is a density-independent factor at play. After the crash, the population may soon build up again, or it may stay low for some period of time. Environments are always changing, and most populations can adapt to a certain amount of change. Populations often grow and shrink in response to change. And finally, major upsets can lead to long-term declines in certain populations. So, for example, one of the things that may be obvious here in the drought that we've had is everybody's yard. I mean, look at the toll that it took on the grass. I mean, you don't think of that as a huge factor, but all of that drought, there's bare patches in everybody's yards, and that the grass could be considered a population because it's a plant. So that would be an example that isn't quite as noticeable, because we don't think about that. We usually think about humans, or we think about animals. We don't think about all the forest fires that have been happening and the tree populations that have been decreasing. So you have to think broad spectrum when we're thinking about living things in terms of how they are affected when we think about population. We're not just focusing on the human population. This concludes podcast 5-2.